should be a pretty good and thorough review of solving quadratic equations. I think there's about 12 examples, and then there's a few examples of factoring, I believe. So let's just start with number 1. Going into these things, you can very rarely be able to just alter the equations and end up with x by itself. Like that can happen, but it doesn't happen very often. I think it will happen once or twice in these examples, but most of the time when you have a quadratic equation, which means it's got an x squared term, somewhere, you really can't just get x by itself, and so you need to use more advanced methods. And our number 1 method to solve these types of equations is going to be, you ready? Make sure that it's set equal to 0, and then follow that by factoring if possible. And then after that, you're going to look to set the factors equal to 0, and that will open up the door to actually solve for x, once and for all. So, looking at this example, right off the bat, we see something that actually cannot factor. X squared plus 3x minus 1, okay, that left side anyway. There is no GCF. And then when you look to see if it can unfoil, it will not. There are no two numbers that multiply to make -1 that also add up to +3. So right off the bat, we're going to kind of finish off our basic, all the full plan. Like if worst comes to worst, and as a last resort, and what do we do if we cannot factor? Well, we actually just bust out the quadratic formula, which you should have handy. I mean, it's on the wall of my room as I make this video in 2018. And another note, I guess, is that the quadratic formula will always work. We're going to need to do it here as like a last resort, but like you probably heard me say in class, quadratic formula will always work no matter if you can factor or not. But for right now, I guess we have no choice. And so a little bit of like side work, I suppose. Since we got to see this quadratic equation, as like a general form of ax squared plus bx plus c equals 0, that would make, in our equation, a equal to 1, b equal to 3, and c equal to -1. And now we can, I might as well write out the formula after all, why not? So that's the formula that you plug A into and B into and C into. So I'm going to do that, and I might need to make a couple comments to highlight. So 3 squared minus 4 times 1 times -1 all over 2 times a, which a was 1. Okay, a couple notes, gang. Squaring this number can sometimes trip people up, especially when b is a negative number make sure that if you're squaring a negative number, then you put it in parentheses, especially when you're thinking about entering it into your calculator, I guess. But squaring a negative number will get you a positive answer. So keep that in mind in case b is a negative number that you're squaring. Also, I find that people lose track of their negatives when they're doing the minus 4ac part, right? A is usually not going to be negative, but C can definitely be negative, and I guess especially when you have a negative in here, like at C, for example, people get that tripped up, People get tripped up, so I guess you'll see how this plays out in a second. So negative 3, and like I was saying, 3 squared that's a little bit easier, I guess, but that's just going to be 9. And then over here, the way I do it is I think of it as negative 4 times positive 1 times negative 1. So keep track of your negatives because that's actually going to be plus 4. And then 2 times 1 is 2. So this becomes, in the next step, 9 plus 4, I just make 13, and 2. And so I'm going to be able to say that I'm done, right? But if this square root was able to be worked with a little bit, like if you could simplify it or something, you would keep going, for sure. But since the square root of 13 is about as far as I can go as far as simplifying that square root, I can be done. I just want to point out one more thing, if I may, sorry. Just please understand that this plus or minus sign basically means that there's 2 answers. And normally you don't have to write them down separately, but I will just for the sake of instruction. That makes one answer negative 3 plus root 13 over 2, and it makes the other answer negative 3 minus the square root of 13 all over 2. So literally it's plus or minus. It's either one. So it means that there's 2 answers here. And I guess one more comment that I just thought of. You leave your answers like this, even though you could totally estimate that if you needed to or if you wanted to. Like the square root of 13 is 3 point something, and it's a decimal, right? It's an irrational decimal. And if you really wanted to, you could estimate both these answers, but usually it's best, you'll see that it's best that you just leave those answers like that. Wow. I don't know how long it's been, but we're finally on number 2. So, once again, our main strategy, since we can't really get x by itself here, we're going to look to set it equal to 0, which means we need to move that term to the other side. So x squared minus 2x minus 24, and the other side would now be 0. Remember, I guess maybe I could have said this earlier. Even if you intend or need to do the quadratic formula like we just did, you still need the equation to be equal to 0. So no matter what, it's like you need to set the, well, not all the time, 100%, but usually you have to make sure that the equation is equal to 0, period. So the next question is, can I factor x squared minus 2x minus 24? So good thing about this topic is we get to review basically factoring also at the same time. So factoring, how do we factor? There's no GCF, but I'm pretty sure this is going to be able to be unfoiled. Remember, x squared just means the bubbles are going to start off with just x and x. And now we think of 2 numbers that multiply, and add up to that. And spoiler alert, it's going to be minus 6 and plus 4. And that's going to be how I factor it. Right? Yes. And so remember the next step, after you have it factored, what you want to do is set both factors equal to 0. So you set this factor equal to 0 and you set this factor equal to 0, and that opens up the door to solve both of these and get some final answers for x. So, making sure I write out all my work. Here and now, see, now you can just get x by itself. What? I distracted myself a little bit. Equals, dummy. And so those are my two answers. And remember that they're two answers like separately on their own. -4 is an answer all on its own, all by itself. Likewise, 6 is an answer all alone, all by itself. You wouldn't plug them both in together. You would only plug in -4 for the x's to double check this, or you would plug in 6. Their answers all on their own individually. Number 3, hey, look at that. It's already equal to 0. How nice. So can we factor this? Because we're going to, remember, I know I'm being repetitive here a little bit, but it's all for the best. Remember, if you can't factor, you got to use what? The quadratic formula. I mean, we could have used the quadratic formula here, but we didn't. So can this factor? I believe it can. Not by GCF, because there is no GCF, but I do believe that this will unfoil. What two numbers multiply to get positive 25, but add up to -10? Okay? And once we have our factors all the way, we can set the factors equal to 0. If you ever want to know why we do it, like why we're allowed to do this, then just ask me one-on-one or in class or something. But there is definitely a logical reason why we do all these steps. Why we set each factor equal to 0, like why that makes sense to do. So here, we essentially really don't have two separate answers. We really just have one. So x equals 5 or x equals 5. That's really technically just one answer. But there we go. So guess what? There's not always two answers to quadratic equations. All right. So again, let's make sure we're following all the proper steps and stuff. Is this equal to 0? Or maybe even first, geez, is it even possible to get x all by itself? No, not yet. But so now we think about maybe setting equal to 0, which, hey, it already is. So can we factor x squared plus 8x? And the answer is yes. And you got to remember that the first method you always try, like I've been saying out loud, is looking for a GCF. And the left side of this equation actually does have a GCF of x. So we're going to factor a GCF of x out, and what's left from the two terms would be an x and an 8. So we factored out an x, and hey, it's factored all the way. So now we, again, nothing really is different. We're going to set the factors equal to 0. And our factors are x and the binomial bubble x plus 8. So we have x equals 0 or x plus 8 equals 0. This one's already done. This one we still need to get x all by itself. And so two answers, x equals 0 or x equals -8. Number 5. We are not able to get x by itself. So we will get everything on one side and basically set it equal to 0. And so -11x minus 8x, that's going to be minus 19x. Okay, so those cancel out, and you just have 0 on the one side. And now we go, okay, can we factor? Is there a GCF? That's what you always check for first. And yes. It's actually very similar to the previous problem, isn't it? GCF ends up being x, and so when you factor that out, you're left with an x minus 19. And then we set the factors equal to 0, the x, which was a GCF, as well as the x minus 19 bubble. That's done. And the other answer ends up being 19. Number 6. We will not be able to get x all by itself the old-fashioned way. And so let's make sure that it's set equal to 0. That 18 doesn't really add with anything, so it's just kind of a separate term, right? The other side is 0, and now we check to see if we can, what? Factor. Is there a GCF? No. Those three terms do not have any factors in common. Can we unfoil this? Are there two numbers that multiply? There is. I already know what they are. So again, it's not too tough to unfoil when the first term is just x squared, and which means the bubbles are going to start off with x and x. So anyway, what two numbers do the job? Those two numbers multiply to get positive 18, but also add up to positive 9. And then, of course, the next step is to then set both factors equal to 0, or all the factors equal to 0. There could be more than two factors. Foreshadowing. And so our two answers look to be -6 or -3. Okay. Number 7. We will not be able to just get x by itself, easy peasy. So we look to factor. Is there a GCF? No, there's not a GCF. So can we unfoil? Can we unfoil? Well, since it's a 2x squared as our first term, it's not going to be just a quick make your bubbles kind of game. It's a little bit more complicated than that, and there's numerous ways to do it. You might like to guess and check and understand that whole deal. There's this method I call the banana split method, which basically involves factoring by grouping and stuff. And I made another video for the pre-calculus classes that I teach that covers more thoroughly, doing both those methods. I'm just going to do the Phoenix method here. All right, but I did cover the banana split method in another video about factoring and foiling and stuff. First, let me double check that this will unfoil. Okay. Now look, I hope you're hearing this and not skipping too far ahead in the video. I'm going to start writing some stuff down just to kind of show you how this works. But you might not want to write what I write until we figure out whether or not this actually will factor, because right now I'm not really sure, I'm not 100% sure if this will actually factor. In fact, I have my doubts, so don't write down anything yet, please. So again, don't write it until I say so. So the first step of the Phoenix method, we do that, and we multiply to the other end. And now we look to factor, right? So the question is, are there two numbers that multiply to make positive 6, but they also add up to positive 6? And guess what? The answer is no. So you know what that means? That means this won't factor, like, at all. And so what does that mean? If we can't factor, what do? We do we have no choice. Even though this formula will always work, it looks like to be our last resort and only choice here. So it looks like A is 2 in this equation, B is 6, and C is 3. And so, okay. Opposite of B, there's a song. Plus square root of B squared minus 4AC. B squared minus 4AC. All over 2A. And of course, this is what X is going to equal. All right, here we go. Let's plug in very carefully. -6 plus or minus 6 squared minus 4 times 2 times 3 2 times A was 2. So 36, and then 4 times 2. So this is like -4 times 2, which is like -8 times 3 is -24. Or if you like to save this negative until later, like just kind of bring it down, you can bring that negative down, right? And then just do 4 times 2 times 3, which is 24. Whatevs. Okay. And so 36 minus 24 should be 12. And oh boy, we have the square root of 12, which we can do more with. Okay, and again, like I've already covered simplifying square roots in class and in another YouTube video. So long story short, the square root of 12 should be 2 root 3 over 4. And guess what? We're still not done, because this 4 will divide into both of these terms up here, and there will be some canceling. So I'll write out very thoroughly how this breaks up. Okay, so the 4 will divide both into the -6 and this 2 root 3. And so now -6 over 4 reduces to -3 over 2. And then here, the 2 and the 4 will kind of cancel to be 1 over 2. And so we get that, which is a pretty good answer. Or, since we have the same denominator, we might as well put these back together into one fraction with that denominator of 2. And remember, technically, that's 2 answers there. Because of the plus or minus, one answer would use the plus, one answer would use the minus. And once again, sorry to repeat myself, but we usually leave answers like that, and we don't usually estimate the square roots and get decimals. Number 8. Oh, hey, all right, here we go. We finally now see an example where you could actually get x by itself by working with the equation, So we could get the x squared by itself really quick by adding 100 to the other side. And, so we have x squared by itself. And do you remember how to, make x squared into just x? Like, what do you do to x squared to just make it x? And the answer is take the square root of both sides. Now, technically over here, you get the absolute value of x. I'm not going to go into that now or anything, and the square root of 100 is 10. But at the end of the day, I guess the bottom line is, because of all this stuff, you end up getting 2 answers. A lot of people kind of bypass this step and don't actually write it down and don't even think it in their heads. So a lot of people just kind of go right from here to here, and they just kind of remember that there's supposed to be two answers, positive 10 or negative 10. But anyway, again, that's an example of, hey, if you can just get x squared by itself and just a number on the other side, you can just take the square root of both sides. Now, in this particular example of number 8, we actually could have done it the way we were doing it before, by factoring. Because I hope you realize and remember that x squared minus 100, so let's write this down again. X squared minus 100 actually factors, right? Not by GCF, which you always check for first, but by unfoil. Right? Now, when would a binomial ever unfoil, right? See, normally when you unfoil, you see trinomials like this. Well, sorry, like more like this. Right? Normally you look at trinomials as things that unfoil. But guess what? As long as you have a difference of two perfect squares, which x squared is a perfect square and 100 is a perfect square, that's when binomials will actually unfoil. And you put the square root of this term in the front of each bubble, and then one bubble gets a plus, one bubble gets a minus, and then you put the square root of the second term at the end of each bubble. So, long story short, I guess, to summarize, when you factor x squared minus 100, you get x plus 10, x minus 10. Just like if you went to factor x squared minus 16, the bubbles would be x plus 4, x minus 4. But continuing on, we can set both factors equal to 0 and then solve each simple equation for x. And, surprise, surprise, we get plus or minus 10, which we already knew, basically, because we did it already. Okay, how about this one? What would we do here? Well, first we'd look to get everything on one side. Negative 14x plus 3x should be negative 11x. I think we've already done at least one, maybe even two examples just like this before, but whatever. Because this will factor. How will this factor? By GCF of x. They both have an x in common. So when we divide out an x from each term, we have an x left over from here and minus 11 from here. And again, nothing really new from earlier problems. We set this factor, the GCF, equal to 0, and we set the bubble equal to 0 also, and then this one's already done. So we got x equals 0 or x equals 11. And yeah. All right, number 10. Let's see what new surprises lay in store for us here. Already equal to 0, that's usually a good thing. Can we get x all by itself the old-fashioned way? No. So we look to factor. First thing we check for, GCF. Is there a GCF? You bet there is, and it's just 3. So we factor out a 3, and we end up with that left over in the bubble. After doing a GCF, people, this is more factoring review, I guess, but you look to see if you can factor one more time. So can this bubble factor again? And yes, so the 3 comes down, and that trinomial bubble will actually factor into two smaller bubbles by easy unfoil. So what two numbers multiply to get positive 6, but also add up to positive 5? Spoiler alert, it's those. And now that you've factored, you can set each factor equal to 0. Okay. I could write out that, like, so 3 equals 0, or x plus 2 equals 0, or x plus 3 equals 0, but what would be the point of setting 3 equal to 0? Rhetorical question, really. I mean, there is no point. If you think about it, you actually could have just divided both sides by 3, and this could have been gone, basically. Like, dividing this left side by 3, this goes away, and what's 0 divided by 3? It would still be 0. So again, you could have literally divided both sides by 3 and everything would have been okay. If your GCF would have been like 3x, then that would have been needed to be set equal to 0. But if it's just a 3 or something, you can just almost like disregard it, because again, setting this equal to 0 doesn't make much sense. So x plus 2 equals 0, or x plus 3 equals 0, and let's just cut to the chase. X is going to equal negative 2 or negative 3. Number 11, okay. If you think about factoring, you cannot. There's no GCF, and the only way this binomial was ever going to unfoil was if it was a difference of two perfect squares, and 6 ain't no perfect square. So, I mean, I guess we could use our last resort of the quadratic formula, right? If you were going to use the quadratic formula, just be aware that a would be 1, because remember, we're talking about ax squared plus bx plus c equals 0. Well, what would b be? It would actually end up being 0, because there is no x term, and then c would equal negative 6. So again, to summarize that, if you were going to use the quadratic formula, a would equal 1, b would equal 0, and c would equal negative 6. But as it happens, this is one of those rare examples that you could actually just get x by itself the old-fashioned way, by getting x squared by itself and just a number on the other side, and then what? Taking the square root of both sides. So let's skip that step like I mentioned doing earlier. What's the square root of 6? Well, that's not clean, and we can't even simplify it. So we're just going to leave it as the square root of 6. Remember, that's exact. We don't want to estimate with a decimal. But just don't forget that when you're doing this square root of both sides thing, that you have a plus or minus answer. And should I do the quadratic formula real quick? Yeah, real quick. Just to see how this would play out. So negative 0. I want a different color. I hate blue. So negative b plus or minus b squared minus 4ac all over 2a. So that's 0 plus or minus 0 squared is 0. So remember, negative 4 times 1 times negative 6. Keep track of your negatives. That's positive 24. Well, guess what? Root 24 simplifies to 2 root 6. And now do you see how we end up with plus or minus? Because those cancel. And so just showing you that either way you should end up with plus or minus root 6. Number 12. I know I'm a little spoiler alert, but geez, I think we're finally going to get to do the Phoenix method and see that in action while, in the interest of solving, really. So again, we always want to get everything on one side, basically setting equal to 0. Remember, minus 12 and these two terms don't mix. There's no like terms, so it's just kind of over here. And now we look to factor. So, is there a GCF? There is not. So I'm going to factor by a special method because this is not easy unfoil. I can't just make my bubbles really quick because of this 6x squared. It complicates things because, it just, like one little comment is, my bubbles would not just start off with x and x. It would need to be 3x and 2x, or 6x and 1x. Which combination ends up being correct? I don't know right now. It's kind of a pain to mix and match all the different ways. So that's why we have methods like the Phoenix method, which just kind of, step by step, get you to the end. So without any uncertainty, really. So remember, the first step is to multiply what we're calling the Phoenix to the other end, and we kill it temporarily, basically. And 6 times negative 12 is negative 72. Now that pretty much now is something we can easily unfoil. So what two numbers multiply to make negative 72, but add up to negative 1? That would be negative 9 and positive 8, I do believe. What's the next step in the Phoenix method? Okay, the Phoenix burned up in ashes. Now it's time to rise back to life by division. So we divide that 6 back in, and remember what we do next is we take these two fractions that we just made, okay, these two fractions that we now have, and we reduce them if possible, and if there's any denominators left worth, its salt, right, we bump it up. So here we go. This is going to be x minus 3/2, and this is going to be x plus 4/3, right? Yeah. 3/2, 4/3. Yeah, should be right. And look, we have this denominator that needs bumped up, and we have this denominator that needs bumped up in front of the x's. So final bubbles, 2x minus 3 and 3x plus 4 equals 0. But we're not done. We're not done because we still have to solve for x. Okay? Now that we've actually factored all that work just to factor, we can set each factor, I hope I have enough room, 2x minus 3 equals 0, or 3x plus 4 equals 0. Solving these really quick. For x, we get 3/2, which is, I think 1.5 is a decimal, which it's an exact decimal, so that's fine. That's fine with me. And over here we get negative 4/3, which is a nasty decimal. So we want to definitely leave it as a negative 4/3. Now, I don't know if it'll occur to you or if it already occurred to you that look at the bubbles we had right here. If you get, to almost like a little bit of an expert level on these kinds of things, you might be able to just kind of get right to your answers from these two bubbles and actually avoid, this final step where you had to bump it up. You know what I mean? It's almost like you were being counterproductive, bumping up the denominators here, but you know, technically these are the two factors, but again, if you're solving for x, you actually could have just went, hey, why couldn't I just take these two bubbles and solve each one for x? And the answer is you could have. Right? Look, positive 3/2 and negative 4/3. Okay, that covers, like, we're definitely going to change gears a little bit because starting with number 13, we're not even solving anymore. We're not solving. This is not an equation. We're not going to solve for x. It's not even an equation. All we're really going to do is factor. And I may have covered this in class. I may not have officially. I don't think I covered it in another YouTube video at this point in time. So here's a quick method that is called factoring by grouping. This method is something you're going to want to consider when you're dealing with 1, 2, 3, 4 terms. That's sometimes a dead giveaway that the method that's going to work great is factoring by grouping. Well, we're going to do some grouping. And you know what I'm going to do actually really quick? Since this is a minus here, I'm going to, I usually don't like to do this, but I want to be crystal clear, actually, that the two terms over here is like a negative 7x and a negative 7. So I'm going to write it as plus a negative 7x. You know, okay, so I like that better. I mean, and I think it might be easier for most students to understand, and especially going into the next step. So when I group these two terms together and these two terms together, I just want to make sure that this negative is with that term, and so we can clearly see what these two terms are in the bubble. Anyway, the next step is, hey, I screwed the heck. Oh, man. The next step is to factor out a GCF from both bubbles, even if that GCF is 1 or negative 1. You're actually still going to bring out, I know normally a GCF of 1 or negative 1 doesn't really count, but in this method it does. So what's the GCF of these two terms? X squared. What's left over from this term is an x. What's left over here when you divide it out? Well, technically a 1. All right, what's the GCF of these two terms? And if the first term is negative, you usually want to include a negative with your GCF. So don't they have like a negative 7 in common, which means when you divide negative 7 away, you end up with x and then a plus 1. Okay? Remember, we're dividing out a negative 7, so we're left with plus 1. Now, you know you've done something right, or that it's working, if you get the same bubble both times. And so that's going to lead into your final answer, where that bubble you got twice is one of your final bubbles, and the other bubble is going to be this GCF together with this GCF in another bubble. And so there's the final answer, because I don't think x squared minus 7 can be factored again. So we're done. Okay. Hey, look at this again. Let's rewrite this so that we can clearly see when we break this up. That it's a minus 8x. And so what's the GCF? Again, x squared, which leaves 8x from that term and just a 5 from there. Okay, what's the GCF from the second group? Really, you know what it is? It's negative 1. I told you. Even if your GCF is just 1 or negative 1, you still divide it out. And so looks like things are working out, because I got the same bubble twice. And then our other bubble is going to be x squared minus 1. Okay, are we done? Can either of those bubbles factor some more? Turns out, plot twist, this bubble of x squared minus 1 can factor again. You should always factor completely and do all the factoring you can when the directions say to factor. How does x squared minus 1 factor? There's no GCF. Can it unfoil? I mean, remember, the only hope that x squared minus 1 as a binomial has of unfoiling is if it's the difference of two perfect squares. X squared is a perfect square, but you know what? So is 1. So we have square root of x squared is x. Square root of 1 is 1. So x squared minus 1 factors into x plus 1, x minus 1. Is this the last one? No, what the? There's two more. Okay, I don't think it'll take that long. GCF would be, geez, x squared again. Plus 2. What's the GCF here? It should be just 4? Yeah, GCF of 4, so that means 3x plus 2. Hey, how about that? And so 3x plus 2, I got twice, so we're in business. X squared plus 4. Does either one of those bubbles factor again by unfoil? Definitely not 3x plus 2. X squared plus 4, remember, it's x squared plus 4, which means it does not. Okay, I know 4 is a perfect square, but it's got to be the difference of two perfect squares. So we're actually done with number 15. Number 16, group those together. Geez, again, x squared is the GCF. What's the GCF of x and 2? Well, technically just 1, which actually counts. And so we got x plus 2 twice, which means things are working out nicely. And then we put the two GCFs to make our other final bubble. And just like the previous problem, this does not factor some more. Just because it's a plus, it would have had to have been a minus. And whew, that does it for all that solving of quadratics, and also some kind of extra bonus instruction on factoring by grouping.